Okay, for many years now, I started my presentation with this picture. I mean, very often when you're out holding this kind of presentation, I don't have a mining audience like I have today. And what is really interesting it is that most people, they do have a picture about a mine. And very often it is about the miner, it's a male and he's very dirty in the face. And he has a cap lamp and the mine is a deep dark hole. So my friends, in the beginning, it was all dark. My name is Peter Burman. I'm the program manager for Boliden Mine Automation Program. And today, what I will talk about, it is roadmaps. I will talk about mine automation. I will go through 14 projects in 5 minutes, and then I will answer the asked for question, is it possible to deep fry a mobile phone? The mine automation, the short story, we are a cross-functional program at Boliden. We are tasked to improve productivity and mine safety. This is the roadmap for 2019, and I will toggle between this one and the one for this year. I know that you can't answer because you're mute, but can you see something really strange? I mean, I know that we have the lag, 1 year is missing, so to speak, but it is that you can see that a lot of deliveries are coming earlier than expected. I mean, it's like I'm 56 years old, I worked as an engineer my whole life. This doesn't happen. And I think this is a message in itself to most of you that it's an indication that a lot of our suppliers are investing quite substantial amount of money into automation and electrification right now. From Boliden's point of view, when we started up the automation program, we were following this model. And if I understand everything right and correct, Greg is Canadian. And somebody in our team read his book. I don't know when it was published. And his idea was more or less that if you want to digitalize the mine, you need to do it in the same way as you have done it in the rest of the society. You start with a telecom system and then positioning services, and then you can go into the process engineering. We have modified that a little bit, and we have number one is building infrastructure, data and positioning services. And then we are started turning machines into robots. And after that, and what I will talk partly about today, it is to robotize the robotization. And then we think when we have done all this, we need to rethink mining. Okay, what have we done for the last 8 years? The mine automation program has been up and running for 8 years, and it was actually a project 2 years before it became a program. So about 10 years we have been up and running. And we have spent quite substantial amount of both money and time to building data communication infrastructure. So today we have 3,000 Wi-Fi access points underground. We have Wi-Fi positioning services in all our underground mines, and we have 2 open pit mines where we had 2 private LTE 4G networks. When I talk about the private LTE network, it is that we have a local core. So the network in itself has local survivability. You have all the components locally on site. And we also have these 2 networks are 5G ready. And in one of our underground mines, we also have a small 5G test network working already. But then we have this thing to turning machines into robots. You can see on the left-hand side. I mean, it's kind of the machines that we are now moving into robots. That said, why I put up these specific pictures has more to do with, I want to see that, show to you that we have a lot of different vendors. I mean, you can see Yama, small Swedish company, we have Epiroc, we have Sandvik, we have Volvo Construction Equipment, we have Caterpillar, Komatsu, etc. And the message I have on the right-hand side, it is that, yeah, it's quite cool that you think about that you are moving the machines into some sort of Mars rovers or robots. But the true story is more like a gray scale. I mean, very often when you move a machine to a robot-like way of working, the first steps seem always to be some sort of remote control. But then we have this strange thing about to robotize the robotization. I mean, today we have, you will see later on in the projects that we have a lot of activities going on in this area, but I can give you one example on what I mean. that is a bit complicated. It is, for example, when it comes to shotcreting or baton spray. Already today, we can buy a machine that in itself has its arm to spray the shotcrete automatically. But the problem is that maybe we will save 20 minutes on that. But during the shotcrete spraying, we need somebody that with a shotcrete truck that is feeding the machine. And we also need somebody exactly afterwards to clean the machine so it will not be destroyed. And this is what we are talking about. When you start to do this kind of robotization, you need to look at all the activities that you have around the machine as well. I mean, it's not good enough to just say, have a tick box and say that, okay, we have a robotic arm, this machine can do the shotcrete on its own. But our point is it's more complicated than that. Of course, we also need to orchestrate the robotization. And in the future, of course, we will have some sort of mine operational center, but maybe it will look in another way. Because in the end of the day, and I guess that most of you companies also work according to some sort of lean model. So what is really important is to keep the flow in the production. And that is also important when you have robotic or remotely controlled machines. So what you can see in the bottom on this slide, it is when we have looked at all the unit operations that we have in a cut and fill mine, and then we see on the different machines. And we also, I don't show you all the data we have here, but you can see that we are looking into what machine types, what vendor, when can they be ready, etc. Do we have any showstoppers, etc. Then imagine that you have a lot of robotic friends in the future that will help you with your work. And then you switch off the light and you leave them. For how long will these robotic friends continue to work? Until they need some sort of human interaction. I mean, it could be that you need to feed them with some, I mean, a drill rig needs drill bits. It could be that you need to do some sort of maintenance. It could be a lot of things that require human interaction. This is what they in the manufacturing call light out time. It comes from electronic production, where they have these machines where they put together circuit boards, etc. They talk about light out time for a specific machine. And what is really interesting, they talk about it as a machine, but also on that specific product that is in the production on the line at that period of time. Because when you look at, you feed the machine with different components, and depending on what you're producing that day, you have different light out time. So this is a message to you that please help me to introduce this concept of light out also in the mining industry. And you must also ask your vendors about what is the light out time on the machine. Because to just to say it's robotics, it's not giving that much lead about could you really run this machine fully autonomously. Okay, how will we then make it happen? Now I will run through a lot of different projects, and please take notes and you can come back to me with questions later on if you found something interesting. First, we have a project called TechSic that we are running together with Ericsson, where we try to benchmark Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, LTE, and 5G. The idea is to see how these networks are behaving when you have a high load of remote controlled machines connected to it, and also other use cases that we have defined. Believe us or not, if somebody of you know about some sort of investigation that is done in this area, please contact me. I have really tried to find something published in the area, but I can't find anything. And it's really, really strange. We are also working with different positioning technologies. In this case, we have a high resolution positioning service that we are trying out based on ultra wideband. It's pretty cool. We are also using Mobilaris, new product Mobilaris on board, where they use its dead reckoning on the machines combined with you had the node graph from your 3D CAD system downloaded in the machine, and you also have the gyros, a lot of different technologies. My point is you can improve your Wi-Fi positioning from plus minus 100 meter on a moving target to plus minus 5 to 10 meter. And that opens up other possibilities, as you will see. In this case, we have made a test robot to measure the performance of the network. And the goal is to be able to publish that on heat maps like the one you see here. In this case, it is just the signal strength, but it could be something else as well. It could be data throughput, it could be latency, like lag. And this is also a message to my friends. It is that I think this is underestimated when it comes to automation or mines in the future, because if you will send 2 robots or remotely controlled machines into an area, you need to know that you have the capacity in your network, or these machines will start to compete about these limited resources until at least 1 or maybe 2 of these machines will go into emergency stop because the heartbeat is not going through. Then we have a project up and running. This is really boring, but it is to connect all the machines that are possible to connect. Today, I can tell you that all Epiroc and Sandvik machines are up. Most Komatsu and Caterpillar as well. Yama, small player, and selected Volvo machines will be up and running next year. This has been surprisingly difficult to achieve. We have seen that some of these vendors have claimed that they have sold this kind of data interface for many years now. But our experience is that, they might have sold them, but no one can have used them. I don't tell what vendor, but when we called them and told them that in your database, this positioning is showing the wrong data. And the answer was, but it's not no problem if you know about it. Okay, we are a bit late in Europe when it comes to automatic haulage. We have been a bit reluctant due to the fact that we have been afraid that it will not be working so far north. We are north of the Arctic Circle. Now we know that these machines are up and running already in Canada. And I think that we will have a board decision later next year. This is a pretty cool project. It is that we will rent 2 wheel loader and a water truck from Volvo Construction Equipment that is remotely controlled. And what the thing with these machines is that they are prototypes, and we are the first company that are allowed to rent prototypes from Volvo. That's pretty cool, because we have told them that it's okay to do technology tests, but for us, the technology is secondary. The thing is, what we need to figure out, it is how can you use them in the production environment. The trial will start Q2 next year. It was supposed to already be up and running, but due to this COVID shit, we are delayed. We are using Simba Opt in Garpenberg mine, so all the long hole drilling is now fully automatic or semi-automatic. We have autonomous trucks trials going on in Garpenberg, Renström, and Tara mine. We are trying out trucks both from Epiroc, 1 project, and 2 projects from Sandvik. We have right now, sorry, this is an old slide, having much cooler pictures now, sorry for that. The trial is ongoing right now with a remotely controlled scaler, and it goes really, really good. We have tried with high resolution 2D cameras and low resolution 3D cameras, and so far we have more or less the operators are in 2 groups. One say they want to have the high resolution 2D, and some want the 3D when they do the working very well. This is pretty cool. We are working together with ABB Robotics to use a standardized industrial robot to do charging of explosives. This project is also delayed. We had the first prototype in November last year, and the idea was to start to load explosives during this fall. Now it's delayed to May next year. This is what we call true Internet of Things. This is the brand of Flygt. It's Xylem, from Xylem. They have now new Internet of Things pumps. These pumps can connect directly, for example, to an ABB system for control. And what we have seen it is that the lifespan for such pump is much longer. This has really been a successful project. This is a project, or more a prototype. We have no intention whatsoever to put this in production, so you can steal the idea. It is that we have put the electrofluorescence in the arms on this jacket, and we also have ultra wideband positioning on each arm. So when you put your arms out and you turn, then the system, the high resolution system, is positioning the arm that is closest to the closest rescue chamber. So we call it the human compass, and it's a project just to show the potential you have in high resolution positioning services. Okay, I know that you have been falling asleep now. You have been waiting for this all the time. Is it possible to deep fry a mobile phone? First, you need some dough, and I must assure you, my plan was to deep fry my own private mobile phone. But when I was out in my cabin outside Skellefteå where I live, I realized the only camera I had was my phone. So sorry for the mock-up. And then you need to measure the core temperature, and then you deep fry 3 minutes on each side. And surprise, surprise, the core temperature ended up in 60 degrees Celsius. And that is exactly the highest storage temperature for lithium-ion batteries. So mission completed. In summary, 14 projects, but the message to you guys, it is that connectivity and positioning service are enablers for more or less all other services. And the story, the stupid story about to deep fry a mobile phone. Remember that this presentation was done for an internal public in Boliden, and the message to my colleagues that is working with mine automation. And my message is, assume that new technology will be working in the mine until otherwise proven. I mean, if you see something, a commercial product that is out on the market, don't make the assumption that it will not be working underground. Take it underground and try it out. Friends, in the beginning, it was all dark. We can now see the light in the end of the tunnel. It's the train coming, and it's written mine automation all over it. And that's the way I have ended my presentation for 5 years now. But maybe if you think about my presentation, I have been wrong. Maybe the ultimate success will be when the mine is totally dark again. Thank you.
Thanks very much, Peter. That was terrific. We do have one question that's come in from Jade Webb. It says, hi, Peter. What is it about the ABB system or the xylem pump that changed to extend the life?
It is more like that they don't pump dry. I mean, it feels when it goes dry and it stops doing the pumping. I mean, you have maybe some features that you have earlier in some control loops, you have been able to fix that. But the beauty on this pump, it is built into the pump in itself. And it also has some self-diagnostic features, like it feels when the, what do you call it? I don't know the English word for it. The pumping wheel, when it is wear down. So it's much better to signal to us and send them error reports. So it's easier to maintain, and it expands the lifespan substantially. We have measured the MTBF, and it seems like in one of the positionings where we had figures on it, the lifespan was 3 times longer. Unbelievable.
There's also a question from Kelsey Gebele. Hello, great presentation. How has automation changed the design of safety shelters? Has there been any recent efficiencies with CO2 scrubbing with automation?
About CO2?
Yeah.
I mean, yes. I mean, one example, I mean, remember that automation is more like a tool that you can use to build. The value is created in the applications that you're building. And we have one application that was built on the positioning service that is ventilation on demand, where you use the positioning service to build geofences. So when you move in and out of different cells, geofences or fan areas, then depending on what machine type that is activated, you can also see if the engine is switched on and off, then you control the fans to get exactly the amount of air that is needed for that machine type or the number on machine. So for example, if you move in with just a pickup truck and some humans, then you're on much lower level compared with if you have an LHD doing its job. And the power saving that we have done is unbelievable. In one mine, it was 54%. And that I could understand because that mine had really a bad control system. But then we installed in another mine that already had a control system, and the saving was 47% on electrical engineering, in electrical power. That said, the power grid in Sweden is quite clean for CO2, so you don't save that much CO2 if you reduce the electrical consumption. But that said, we have propane for heating the air during the winter when it goes in to prevent the freezing of shaft. And I think the reduction of the propane was about 20%.
While we wait for some additional questions, Peter, I have one that I was curious to ask you from the presentation, which is, you talk a lot about, I'm going to screw this up, but robotizing the robotics. Okay, I've already screwed it up. And you talked about things like, what's behind one machine and what it takes to get that up and running, and the lights out idea behind it. My question is about the mining cycle. So you're doing things like automated scaling, charging. Have you been able to address the entire mine life cycle from a robotization perspective, or are there things like face preparation that still need to be done from that perspective?
I mean, if you look at what we are aiming for right now, if I started for the blast cycle for a cut and fill, I mean, you saw the machines that we were working with right now to bring in from Volvo Construction Equipment. The idea is after the blast, you will go in with a controlled wheel loader, and then you push the blast in a pile. Then you back out, then you go in with a water truck and do the watering. Then you take the wheel loader again, you load out. Then after that, you can go in with a scaler. After scaling, you can go in with a wheel loader, and that will be 5 operations. After that, we have the shotcreting, and the shotcreting we have not solved, but we have a robotic, what do you call it, bultrig, doing the bolting. So we are looking into right now. And after that, we have, is it the face prep coming down? I'm a bit tired now. So then you have the scaling of the face, and then the cleaning before you start to do the drilling. So these two are also fixed. And then you have the drilling in itself. There we have problem because we have hard rocks. So we have no drill bit changer. So it's hard to put the boomers that are doing the driller into fully autonomous drilling. And then you have the robot that will do the charging. So I think that the weak spot right now is we have not proven that the charging will be possible to do. We are not doing the shotcreting, and we are on the early trial phase on the bolting. Was it an answer on your question?
Yeah, I think so. Because some of the underground mines that I think exist elsewhere, in trying to do things like face prep and identifying bootlegs and picking up lifters, it's hard to do that as part of the full cycle. But it sounds like you've been approaching it in a fairly systematic way with the largest pieces of equipment that do the most, and being fairly systematic in the approach.
Yeah, the ambition is, I mean, that has been quite interesting thing with our mine automation program. It was when we started up, we were convinced that we will be able in the future to do the robotization of the mine, and people were laughing. It was 10 years ago, and at least now they have stopped laughing. So we will see how long time it will take. It always takes more time than you expect. So I mean, if I think that we could do the full cycle in 3 years, it will probably take 5 or 6.
And I think there's another question that probably leads into that point about the time that it takes to do this. And I know you had a slide that you went through fairly quickly at the beginning, but there's a question from Jeff Sterling from Universal Field Robots. It says, great presentation. How do you evaluate projects are worked on? Do you have an overall strategy or roadmap for automation? What timeframes you had for various processes? Maybe you can go back to those slides, because I think that was something that might be addressed from the presentation.
Let's see if I can get. It was a roadmap you wanted to look at.
There it is, yeah.
This is the top roadmap. To understand this, you can see on the left-hand side, you can see the color. It is the autonomous machines is one focus area. You have production control. The red one is another focus area, and infrastructure is one. We also have maintenance that is started up now. It's not in this roadmap, it will be for 2021. So you can see that the infrastructure are mainly doing deliveries of up to production control and to autonomous machines, because the value is more or less created in production control autonomous machines. Infrastructure is just creating cost, I would say. Then to understand this is a hierarchy of roadmaps. The thing is, this is the only one that we share externally. It has to do with the fact that under autonomous machines, they have their own roadmap that is much more detailed, where you can see all the vendors and the promised delivery dates. But we can't show that, because then we are outing our vendors, and they are really upset when we are under NDA and we show their roadmaps externally. So generally speaking, yes, we have a lot of substantial work that is put into roadmaps every year. It's broken down on the focus areas. Each focus area has its own focus area manager. And then it's my job as the program manager to compile this and get it to some sort of overview roadmap. And it's actually this boring top view roadmap is the only roadmap that will get approved by the steering committee of the program. So this is the only one they see as well, because we don't trust management to give them the detailed roadmaps, because they will sooner or later use it in the presentation. So you need to keep it management safe.
There's another question that says, what would be your top 2 suggestions for the mines who are just beginning their mine automation journey? From Gurpreet Bhatia.
It is to start so you must take the cost to a good connectivity. That is really important. And the problem is that I have received this question so many times. It is that people come and, how did you succeed to make the business case on the installation of a data network in a mine? My message to you guys, it is that a data network don't have a business case. You must think about this. It's like having a business case on the foundation on the house. It is the applications that you build on top of it, or the house that you can rent out and get some money for in the case of the foundation. In this case, is it the same thing? I mean, you don't do a business case on the water supply or the air supply. I understand you can do it partly, but you see where I'm coming from. You need to look at it at a necessity that a modern mine will need, because then you can start to earn money by doing ventilation on demand. You can have a better control of the workforce. You can do much more better planning. You will have an easier way to measure things that is going on. It could be ventilation, but it could also be pumping, dewatering. You have all the error reports coming from the machines in a much better way. I mean, you can also have IP telephony, so you don't need to have double infrastructure. You can scrap the old push-to-talk phone and use IP telephony instead. You can call each and every individual in the mine when you have IP telephony, and you don't need to have all the communication going in open lines. And believe me, that is a good thing, because it's not always a good, smart thing to start yelling at people over an open channel. But sometimes it's needed. It's much better to call that individual. It's a lot of things that will improve your productivity. So I would say positioning service and the data connectivity. But that is not the value. The value is what you build on top of it. And then you have the safety aspect as well. I mean, the emergency services that has looked into the positioning service we have right now in our mines. They claim that a rescue operation in the mine in case of a fire, for example, they think that they can act 1 hour faster now than they have done in the past, because to just get control over all the people were with the old push to talk radio took about 1 hour. Now when they arrive on site, everything is just, you can just print it out from the system, because the system knows exactly where everybody are, and if somebody is lost. Hope it was an answer on the question.
I think that's a really good answer, especially related to like which use cases were the highest value that enabled you to make that decision of connectivity. There's a follow-up question from Madeline Martinson, which is what was the biggest challenge in starting the automation journey?
I mean, it is to get the understanding from the organization that they can find value in this kind of investments. I mean, it's the same thing all over the place. I mean, what's the point to develop new technology if no one has the ambition to use it? So, I mean, if you look at my presentations, you can see that I'm using an individual that is much better than me in drawing to help me to do my presentations. You see that I have a quite selling approach. It's not because of you, my friends. Boliden is not selling anything. This is internal sell. That's why I need to be skilled in this kind of presentation, because I need to sell and sell and sell and sell the idea about automation to the people internally in the company every day.